Hi everyone, I hope you're doing really well today. I really wish I could be in person to do this, but nonetheless, I think this should be a really good introduction to what wave energy is, and I am looking forward to giving this presentation. Hopefully it's useful to many people. Kind of goals of this presentation, I really want you to learn a brief introduction to what marine energy is as a whole, specifically wave energy, renewable energies in general, the different types of energy, what energy is, and how electricity is produced. So why am I talking to you about this today? Well, my name's Abigail. I'm a graduate student at the University of Washington, so this means I've gone all the way through college. I graduated with a degree in mechanical engineering a couple years ago, and I just wasn't done with school yet. I had so much fun that I decided to continue on into grad school, and that's where I am now. I'm studying mechanical engineering at the University of Washington. Specifically, all of my work is in a field known as marine energy. And so that is all about getting energy from the ocean. So trying to power things using energy from the ocean. So that's kind of where all this lies. And the reason I'm coming to you today is I'm part of a competition team at the University of Washington called Washington Wave. And we are part of a national competition to design and build and test a device that can produce electricity from wave energy. And so we wanted to produce some sort of educational content to go along with that. So that is what this is. So first off, I want you to think about what energy is. Like, if you know what it is, note that. If you think you know what it is, if you have no idea, it doesn't matter. We're going to learn a lot about that today. But energy is what gives us the ability to do things or do work. So work is a fancy way of describing making something move. And that's basically my role as an engineer, is being like, okay, I want things to move, right? I mean, static things are fun for civil engineers, but mechanical engineers like things that move. And so that's work. Something has energy if it has the potential to make something move or the potential to do work. So everything has energy, and when we release that energy, we can do work with it. We need energy stored in food to think, we need energy stored in food to think and move, and the world needs energy to power our factories, homes, and cars. So bringing that back to, I want you all to think about, do you know about wave energy? Do you know anything about wave energy? Think about if you know where the electricity that powers your lights comes from. But we're going to talk about both today, so it's totally fine if you don't. Let's go ahead and get started. Well, maybe. So here are a bunch of ocean waves. What are some things that come to mind when we think about the ocean? I'll give you a second. But the ocean is filled with waves, and these waves can be really powerful and they move a lot. Because of this, we can use them to make electricity, which is exciting, and we can use that electricity to power all sorts of things, both on land and in the ocean. We are here today to talk about how we can turn all this movement into electricity. So anything out in the world that is moving a lot has a lot of energy, and kind of our role as a team, and a lot of what I do, my work is right now, is looking at the ocean specifically and saying, okay, we know it has a lot of energy, but how do we actually get that energy and use it? Like, what can we do with it? Like, how can we grab it and use it to our advantage? How can we use it to do things? How can we use it to do work, right? All about making things move. We specifically call turning all of this energy that's stored in the waves in the ocean, the waves specifically, as wave energy. But in order to understand wave energy and what it is and how we can utilize it, we have to learn about a couple of things first. So today we're going to learn about what energy is. I've described it a little bit, but we'll go more in depth. And then we're going to learn about how electricity gets made. And then we can learn about wave energy more and why it is so cool. So I've already asked this, but I'm going to ask it again. What are some things you think about when you hear the word energy? Some common things are you might have a lot of energy if it's a really good day, or if you had a lot of sugar, or you had a great night of sleep, or you're really excited to do something. You might think of things of having energy when like a battery's charged or something, like your phone has full battery, it has a lot of energy, a lot of potential to do things. You might think of vehicles and things, or how your muscles move and release energy so that you can actually like lift something up. So it turns out that energy is actually pretty difficult to describe. Energy, like I said earlier, is the ability something has to do work. And again, work is just a fancy way of saying to make things move. So we see energy all around us, from the food we eat to the electricity we use. So if something is moving or can make something move, it has energy. Again, my job as an engineer is to look at the world and think of all the things that have energy and how I can harness that energy for different things. So in order to learn more about what wave energy is and how electricity is produced, we're going to learn about two types of energy. There are many types of energy, but most fall into these two categories. The first is potential energy. Potential energy, pictured here on the left, and this guy with the brick, is the energy stored in an object. That is just sitting there waiting to be released. While the brick may not look like it has any energy because it's still and isn't moving, it has gravitational potential energy because it is held in the air and gravity is trying to pull it down. So as soon as this guy lets go, the brick will start falling and moving, i.e. work, because gravity will pull it to the earth. It is the potential to fall thanks to gravity. And thanks to gravity, the higher you lift an object, the more and more gravity wants to pull it down to the earth. And so the more gravitational potential energy it has, because it can fall for longer. We can thank gravity for that. The next is kinetic energy. Kinetic energy is the energy an object has when it is moving, like it is actively in motion. So once you let go of the brick and it starts to move, the gravitational potential energy begins to turn into kinetic energy. And an object can have both potential energy and kinetic energy at the same time. So if something's off the ground, but it is moving, it has both potential energy and both kinetic energy. Because there's the potential to fall more, but it's also actively falling, so it has both. And we can see that in this lovely GIF of Obama and his mic drop on the right. And so when he's holding the mic at the top, it has a lot of potential energy because it's the farthest it is from the ground. But as soon as he lets go, some of that potential energy is turning into kinetic energy because it's starting to move and it's getting closer and closer to the earth. So there's the two main types of, those are the two categories of energy, and any types of energy we see in the world fit into one of those categories. So to learn a bit more about these types of energies, we're going to watch a short video.
Welcome to the International Space Station. I'm astronaut Joe Acaba. Today, we're going to talk about potential and kinetic energy. Let's get started. Kinetic energy is the energy an object has because of its motion. An object can store energy based on its position. This is called potential energy. On Earth, imagine dropping an object from a raised position. As an object's altitude above the Earth's surface increases, its gravitational potential energy also increases. The potential energy stored due to its position is now being converted to kinetic energy. We also observe this with elastic potential energy.
Okay, new term. Elastic potential energy occurs when objects are compressed and stretched, or generally deformed in any manner, creating potential energy. Think of this bungee or a spring. Okay, Joe, what's next?
We pull back on the band and create potential energy. When we release the potential energy, it is converted to kinetic energy. Here on the International Space Station, we are still under the influence of gravity, primarily due to our position with the Earth. So when I have this ball on this ramp, normally back on Earth, I release the ball, and it rolls down the ramp due to a change in its potential energy that's being transferred to kinetic energy. But as you can see, it doesn't happen here. So it doesn't mean we don't have potential energy. It just means we're not converting it at this time to kinetic energy. And why is that? Gravity is pulling us down, but we're moving super fast. And so what it is we're bending around the Earth in this perpetual falling motion. Thanks for joining me on board the International Space Station. We're sending it back to Earth so you can try your own experiment. See you next time.
Okay, so in summary of that video, we basically learned that, again, there's two types of energy. There's potential energy and kinetic energy. And often there's some balance between the two, like we're transferring potential energy into kinetic energy. You have a lot of potential energy when you're raised off of the surface. You have a lot of kinetic energy if you're moving really, really fast. And you can have both at the same time. Many things have both at the same time. And the big point of that video is that energy cannot be created or destroyed. So we have this pool of energy on the Earth, and we can't change it. We can't create more of it. We can't destroy it. We're always going to have this set amount of energy. And so electricity and producing electricity is all about how to transform all those different types of energy out in the world into electricity, so electrical energy. And we do this by developing devices that are intended to transform this energy. So energy cannot be created or destroyed, but it can be transformed. And so we're going to talk about that a little bit more in this video, how that sentiment relates directly to producing electricity.
The law of conservation of energy. It may sound like some sort of legal requirement to save energy. Turn off those lights when you leave a room or you'll get a ticket. It's really one of many laws of physics, and it says that energy cannot be created or destroyed. You're probably thinking, that can't be right. The line energy creates energy, electricity. But we don't actually create it. We start with energy that already exists in natural gas, coal, wind, and other sources of energy, and then use our generating processes to transform it into the electric energy that you use in your home. That's what all the equipment in our generating facilities is for. We transfer the energy from a raw resource into something more useful. However, even though energy can't be destroyed or lost, it can be wasted in the transfer from one type to another. Think about light bulbs. They transfer electrical energy into light, right? But older bulbs, like incandescent light bulbs, transformed electrical energy into light energy and heat energy. A lot of electrical energy was wasted as heat energy. That's why LEDs are so much more efficient. Nearly all the electrical energy transforms into light energy. So, energy is constantly changing forms, but it's not being created or destroyed. It's like the law.
If you only remember one thing from this presentation, I truly want it to be that energy cannot be created or destroyed. It can only be transformed. And that's what this video is getting at. It was summarizing that again, but also under the context of power generation, so how we actually make electricity. So now we're going to dive into how different types of energy are used to actually produce electricity. So to do this, I'm going to talk about what I call the road to power. This is the basic map for how all electricity gets made. It takes a couple of steps to produce the electricity that powers our lights. And to make electricity, you first and foremost need an energy source. And you might be able to think about a lot of these. They talked about a couple in the video we just watched. But in general, there's kind of two categories. Again, we like our categories here. So the first is fossil fuels, and these tend to be the older energy sources. We can think of things like oil, coal, natural gas, kind of those very traditional sources. And then there's another category known as renewable energy, and this is particularly what I'm excited about and where I think the world should be headed and is headed, thankfully. And these are sources that are more out in nature, and yes, fossil fuels are found in nature, but they require a step of burning in order to produce electricity, which releases a lot of bad things into the environment. Versus renewable energy, you don't need to burn anything and therefore no emissions. And so renewable energy sources are things like wind and solar and wave energy and other energy that is available in the ocean. And there's many more types of renewable energies out there, and this is where a lot of development is currently happening, and so that's really exciting to me. So to make electricity, you first need that energy source, which we just talked about, and then you need to be able to harvest the energy from this source and transform it into electrical energy that turns your lights on. Remember, we can't create energy. We can only take energy from something that's already there and transform it into a different form of energy. And this takes place in the step I call the energy change. And this is where a lot of engineering comes in. In this energy change, you have to develop a device that is able to harvest the energy from the energy source and transform it into electricity. This energy change step often includes a generator, which is what they showed in the video earlier. And that's basically, it takes rotational movement and motion and turns it into electricity. And there's many different types of generators, and I'm not going to get into that today, but that's a huge component. You basically take a bunch of energy that's in your energy source. It can be potential or kinetic or both, and you use that using the device you've created in order to turn something that causes rotation in a generator, which produces electricity. That's kind of the general roadmap. And that energy change piece is largely where I focus. But this basic roadmap kind of gives us the tool to look at the rest of the world and say, okay, there's this thing out there that has energy. How can I build something to harness that energy and turn it into electricity? So there's lots of sources out there, and this is where a lot of creativity is needed for future development. So we're going to first talk about fossil fuels. So like I said earlier, these are more traditional sources of energy for electricity, and they include natural gas, oil, coal. And the energy change typically takes place in big power plants, and the reason this isn't great is because you require burning of the fossil fuels in order to boil a bunch of water, produce steam, and then that steam turns a giant turbine, which in turn turns a generator to produce electricity. And the problematic part about this is, fossil fuels are pretty destructive to harvest. Like, you need to mine them, or in the case of oil and natural gas, you have to drill for them, and that has its own environmental impacts. But more importantly, the burning process releases a bunch of bad things into the atmosphere that are harmful for our health and the environment, and these are known as emissions. This is why renewable energy is so important. So renewable sources, like I said earlier, the most common ones that we kind of think of are like solar and wind. And we also have a lot of hydroelectric power in Washington, which is just storing a bunch of water behind a dam, and then when it's released, it turns a turbine to produce electricity. Dams aren't great though. We don't want to build any more of them. We already have a lot of them, and they have their own environmental impacts. So a lot of renewable energy research is focused on things that have much fewer environmental impacts. But the great thing about all renewable energy sources is that you don't have to burn anything, and therefore you're not releasing those bad things into the atmosphere like you do when you burn fossil fuels, and so that means lower emissions. The question I have for all of you that I want you to take a little bit to think about, go ahead and pause this video, is, do we think wind has kinetic or potential energy, and what about the sun? So wind is a perfect example of kinetic energy since it's moving. This is rather obvious. We can feel it. We walk outside, it's a windy day, we can feel the wind. But what about the sun? The second question is a little tricky since it may not seem like anything is actually moving in sunlight, but stuff is. Sunlight is full of kinetic energy because sunlight is actually made up of a bunch of tiny little waves of heat and light, which move between the sun and the earth. Even though it may not seem like it, things are moving in sunlight, and therefore it has kinetic energy. So the energy change for renewable energy sources like wind takes place in turbines, which spin a generator to produce electrical energy. Unlike fossil fuels, though, you don't have to burn anything to do this. The wind is already moving. For solar energy, the energy change takes place in a solar panel, which is full of a bunch of photovoltaic cells, which take the sunlight and make little electrons move, which produces electricity. The awesome part about all of this is, again, you don't have to burn anything, and therefore the environmental impacts and health impacts are so much lower. And this is really important for the future of our climate and also our own health. That's why renewable energy is so important. So the specific energy source I'm going to be talking about for the rest of this presentation is wave energy. So wave energy is specifically the energy that's available in the ocean specific to waves. So if we have something on the surface that's moving with the waves, like what kind of energy can we capture? That's wave energy. And so we can use wave energy to produce electricity, much the same way we do anything else. And it turns out there's a lot of energy in the ocean. But the tricky, challenging part right now is the energy change. So the energy change is where most of the research is, right? It's how can we develop a device that can sit at any place in the ocean and turn all of the energy that's available in the waves into useful electricity. So how do we build that device? But in order to build that device, we have to think about a very important question, and that is, what types of energy do waves have? So again, we're going to talk about categories here. So we got kinetic energy, potential energy, or both. What do you think? So it turns out waves in the ocean have both kinetic and potential energy. They have potential energy because they change in height, so they have differing amounts of energy due to gravity, like we were talking earlier. They have, as they're going through time, the wave height changes, and therefore the distance to the center of the earth changes, and therefore you have differing amounts of potential energy at any point. But they also, and this might be more obvious, have kinetic energy because they're moving, right? We see big crashing waves, so that's the kinetic energy. So a lot of the energy change takes place in a device known as a wave energy converter, as the name slightly suggests. And these devices can look very different. This one in particular is called a point absorber, and so it sits on the surface of the ocean and moves up and down with the waves and captures the energy that way. And so basically on the inside of one of these, you might have some sort of system that turns this vertical motion into electricity through the use of a generator or something like that. And then you can get electricity out of it. So these devices can look like all sorts of things. There's so much research here right now. We don't really know what they should look like or what works best yet, which is really exciting. There's lots of room to play and design and see what happens. And that's where we fit in as a team, is figuring out our own idea for one of these devices. And so they don't have to be, and so these devices can look super interesting. They can sit on the surface of the ocean, they can sit on the floor, they can sit somewhere in between, and it's all just trying to convert that wave energy into electricity. So that's kind of an overview of the road to power and a brief overview of wave energy. And from now, we're going to focus on the energy change. But first, I want to do a quick activity break. that I think is pretty cool to show you where your electricity actually comes from in your state. Now, I'm in Washington, so I'm going to look at this specific to Washington, but I highly recommend that you check out this link and explore a little bit more on your own. So my discussion question here is, what types of energy sources do you think most of your power comes from, most of your electricity? So when you are at home and you turn on your light switch, where is all that electricity coming from? Okay, so this is a New York Times article, and I think it's really cool. But this is an overarching map, not map, but graphic that shows all of the energy production, electricity production in the US over time since 2001. We can see here, but just by the shape, that, before like 2015, coal was huge for most of the US. About 50% of our electricity was produced from burning coal, right? A fossil fuel. Bad emissions. We can see that that has kind of come down. We still are largely about like over 50% fossil fuels, but we can see that a lot of the renewables down here, so hydroelectric, wind, and some others are, slowly increasing, but we wish this was happening faster. All right, so like I said, we're in Washington here. Well, I am anyway. I am presently in Washington. So we're going to look at Washington. And like I said earlier, a ton of Washington's electricity is actually produced from hydroelectric power. This is cool because it is technically renewable, but we really don't want to be building any more dams. And if we want to get the whole world completely on renewables so that we don't have those bad emissions, then we really do have to focus on those other renewables, such as wind and solar and wave energy. And you can see it's like fluctuated a lot in Washington. Okay, I wanted to show you another state. So I moved from Montana, so I thought I'd check them out. So we can see that hydroelectric has increased a decent amount over time, and thankfully coal has decreased. We still have a lot of work though to kind of bump up the wind and other renewable sources. This is largely the reason I'm doing this presentation today, because I think it's important that we give a lot of basically motivation behind why we want to switch to renewables, and background on, where we stand now and what they are, and kind of just spread the word about how awesome renewables are. So here what I'm showing is a map of the world, and the red basically shows areas where there's a lot of wave energy available. And the dark blue areas are where there's very little. And we can see that off the coast of Washington, there's actually quite a bit available. And this is awesome, also around Alaska. And what we can see though is wave energy is available around the world. And this is really cool because we can use wave energy in areas that might not have the best access to other types of energy. It might not be very windy. Maybe it's really dark in the winter, like up in Alaska, but we still need to produce power for those areas. And so wave energy might be a way to do that. It also can be used to support areas that might not be able to produce all the electricity they need. For example, Nigeria in Africa, they have a power gap right now. So they physically don't produce enough electricity for everyone in the country to have a cell phone. So things like wave energy can be used to give countries a lot more independence over their power, and help build up the country as a general, and like improve the livelihoods of everyone there. So there are lots of things we can power with all of this available energy. Specifically, there are lots of things in the ocean that need power, like growing food or aquaculture. So lots of food is grown in the ocean, like seaweed and fish farms. And as the world population continues to increase, this becomes even more and more important, and we need to sustainably feed the world. And so aquaculture could be a great option, and wave energy could power that. The next thing is science. So the ocean, there's just so much still unknown about it. We need to explore it more, but it's really hard to power things in the ocean. Batteries can only do so much, and cables from shore are really expensive. So something that's already out there, like a wave energy converter, could be used to produce the electricity needed to power a submarine or something, or a camera that's on a line out there, or even just weather stations, just so we can have more of them out there. And this way we can learn more about this largely unexplored area that takes up most of the Earth, by the way. This power can also be used to give electricity to small isolated communities. I described the example of Nigeria earlier, but it can really make a huge societal impact across the globe. Also, we specifically, our team, Washington Wave, where I'm coming from to talk to you today, is specifically working on what we call a hazard buoy. And so our buoy is intended to power different devices that can warn communities about things going on so that they can prepare for them. One example would be tsunami sensors. So we could use a wave energy device to power a tsunami sensor on the ocean floor, which would alert local communities that a tsunami is coming. And there's many more examples of how these could be used. So overall, I hope this was interesting. I really am excited about wave energy, and I hope you are too now. My intent for this presentation was to give an overview of what energy is, and so that you could leave feeling like you could look at the world and think, okay, this is something out there that I know has energy, and so that I found an energy source. But how might I create the energy change? Like, how might I produce and design a device to actually change that energy or transform that energy I see in the world into something useful like electricity? And that is largely what engineers do. And I think it's really fun and exciting. It requires a lot of creativity, and we need as many minds as possible working on these complex problems. And that is why I wanted to present this to you today. So I really hope you can go out in the world and think about these sorts of things, because the more minds thinking about it, the more perspectives, the more things we can develop. So because this is a lesson, I wanted to end this with a quick quiz. So I want you to think about these questions, maybe pause in between so you can give your own answer. But what did we learn about wave energy? First, what is the difference between potential and kinetic energy? Potential energy is energy stored in an object, and something has kinetic energy once it starts moving. So potential energy is something that's stationary. It's not moving yet, but maybe it's high off the ground. It has the potential to move. Kinetic energy is something that is moving already, and objects can have both. Can energy be created or destroyed? Now, if there's only one thing you get from this presentation, I think this should be it. No, energy cannot be created or destroyed. It can only be transformed. It can be turned into a different type of energy. We have a finite amount of energy on this globe, but we can turn it into different types of energy. We can't create it or destroy it, however. So how is electricity produced then? So we take something around us that has energy, and we transform that energy into electricity using a device that we build. So again, this is where we need so much more creativity and thought and work and a lot of engineering. So once we've created this electricity, what can we do with it? Specifically, what can we do with wave energy? So we can power all sorts of things in the ocean, like growing food and learning more about sea life, which is all very important. So in summary, we hope you leave here today with the curiosity to look at the world and think of what other energy sources you could harvest to produce electricity with. How could you capture and transform this energy? How might you build a device to do so? Anyway, I really hope you all enjoyed this. I hope you have a great rest of your day. And I hope you are able to look at the world through a little bit of a different lens now, and maybe have a little bit more of an understanding about how all of these complex things work. But anyway,